we're working on operations with radical expressions. We're going to do number 1 together. Yes, I'll sharpen this. First thing I would like you to do is I would like you to set this equal. We're going to write an equivalent expression. Okay? In the numerator, what I'd like you to do is put c to the 4th, d to the 7th in the numerator. And in the denominator, I'd like you to keep it as 128. So you got the square root of radical c to the 4th, d to the 7th, over radical 128. That's our first expression that we're rewriting it as. I'm going to highlight the top in blue and the bottom in green. We're going to try to simplify these separately. All right. So whenever you're dealing with fractions, focus on evaluating or simplifying the numerator and then simplifying the denominator separately. It makes it a little bit easier. All right, even though we can't see it, what is the index that goes right there, even though we can't see it? Oh, that's a 2. Okay, this is a square root. So I'm going to put a 2 and a 2 right here to help you guys understand. You're looking for groups of 2. So let's focus on the numerator right now. 2 goes into 4 how many times? 2. So on the numerator, you're going to have a c squared. 2 goes into 7 how many times? Not 4. 3 times, right? But not evenly, because 2 times 3 is what? What's 2 times 3? 6. But we have 7. What does that mean? That means inside of the radical, what do we still have left inside of this radical? We have 1 left over. So I want you to put 1d right there. Now, does anybody remember from yesterday when we talked about when you have an even index and you have an odd exponent in a variable, what do we have to place on the outside of this variable? That's right, absolute value bar. So I'm going to put absolute value bar here and the absolute value bar right there. So in the numerator, here is what we have so far, completely simplified in the numerator. We have a c squared. We have the absolute value of d cubed times radical d. That is the total. That's the numerator totally simplified. Now, we made a list yesterday of 2's going down, and we stopped at 2 to the 5th. 2 to the 5th was equal to what? 32. 2 to the 6th, 64. 2 to the 7th is equal to 128. So what I want you guys to understand right here, 2 to the 7th is equal to 128. So right here in the denominator, I would like you to put radical. But 2 is the index. And I want you to go 2 to the 7th. Okay? 2 to the 7th. Now, 2 goes into 7 how many times? 3 times, right? So we're going to have 2 to the power of 3, but what do we still have left inside of the radical? 1 what? You have 1 2 left. So you're going to put 2 right there. All right, another way of looking at radical 128 is saying it's radical, and I'm going to list out 1, 2, 3, 4, 5, 6, 7. 7 2's being multiplied themselves. Now, how many pairs do we have? We have 1, 2, 3. See how we have 3 pairs? So 3 of those can come out. But what do you still have left inside? You still have a 2 left inside. So that's why it's 2 cubed. And by the way, what is 2 to the 3rd power? That's actually equal to what? 8 radical 2. So here's what we have. We have c squared. We have the absolute value of d cubed times a radical d. Now everybody, we only have one thing we got to clean up. The radical 2 right here is what's considered to be an irrational number. whenever you're asked to simplify something, so if you ever see the word simplify, and you're dealing with radicals, you're not allowed to have irrational numbers or radicals in the denominator, okay? Just like when you go to the store, you can't buy the square root of 2 apples. It's not possible. It's like 1.4 something, all right? That would be very difficult. It's an irrational number. They would look at you irrationally if you asked them. Now, how do we get rid of a radical in the denominator? Now, we've done this before. We have to take the numerator and the denominator and multiply them both by the radical that we're trying to get rid of in the denominator. Which radical are we trying to get rid of? That one. Radical 2. So we're going to multiply the numerator and the denominator both by a radical 2. So right now, we are simply going to simplify the numerator first. So in the numerator, what do we know for sure is the numerator? We know we have a c squared. We know we have the absolute value of d cubed. Okay? But how do we rectify this situation of a radical d times a radical 2? Well, let me tell you. A radical d times a radical 2 is just simply a radical 2d. Whatever number is inside of this radical, you multiply to whatever number is inside of this radical. So right here, what am I going to have left? I'm going to have a radical what? 2d, right there in the numerator. Hold on. Next part. What do we have right here? We have a what? We have an 8 radical 2. What are we multiplying this 8 radical 2 by? Another what? Another radical 2. Now, which numbers are inside the radicals? 2's. So what is 2 times 2? So we have 8 radical 4. But wait, what is radical 4 actually equal to? So this becomes 8 times 2, which is 16. So what actually goes in the denominator, everybody? 16. Now, all right, quickly we're going to review real quick, all right? We simplified the numerator, we simplified the denominator, but the problem in the denominator was this radical 2. So what do we have to multiply this denominator by? A radical 2 over 2. That's called rationalizing the denominator, okay? Radical 2 times radical 2 is actually what? It's actually radical 4. But radical 4 is 2, so 8 times 2 is 16. That's how we got the 16 in the bottom. Up here, what do we have to multiply together? We had to multiply the radical d times the radical 2, and that became radical 2d. So our final answer, everything is simplified. Why is this simplified? Because now we don't have an irrational number in the denominator. What do we have? We have a rational number in the denominator. So the process we just did was called rationalizing the denominator. Okay? All right. Right now, what I want you to do is I want you to do number 2. So practice number 2. You can pause the video, see if you get it right. Not going to do it. Here's the first step. I'm only going to give you the first step. There's the first step. All right, so if we look at this right here, what is the square root of 9, everybody? 3. And if our index is a 2, how many times does 2 go into 5? Twice. But it doesn't go into it evenly, right? We have 2 times 2 is 4. How many do we have here? We have 5. So what do we still have left inside of the radical? We still have 1 left over inside of the radical. In the denominator, what's the square root of 64? 8. And if our index is a 2, 2 goes into 4 how many times? 2. And this is our final answer. Why do we not need any absolute value bars, even though we had an even index? Because with our variables, we had even exponents. We didn't have an odd exponent. We had even. Good now. That's your final answer. All right, looking at problem number 3. Here we go. I'm going to highlight some things on problem 3. I'm going to highlight this 3 and this -4 in one color. I'm going to highlight the 15 and the 45 in another color. Whenever you're multiplying with radicals, the numbers that are on the outside of the radical get multiplied together. The numbers on the inside of the radical get multiplied together. So that's why I highlighted these in blue and these in green. So right now, what can we multiply together? The 3 and the -4. What does that get us? -12. Very good. Now, inside of the radical, what are the numbers that we're going to be multiplying together? 15 and 45. But instead of multiplying 15 and 45 and getting the product, I just want you to write 15, put a dot, times 45. Okay? Now, what we need to do, everybody, is we need to break down the 15 and we need to break down the 45. What are some factors of 15? 5 and 3. What are some factors of 45? 5 and 9. Okay, 15 and 3, right? Either way, someone's going to put right here, we're going to put 5, I'm going to put a 9. Only one of these can be broken down anymore. The 9, what does that break down to? 3 and 3. So here's what I want you to write in your journal. Here we go. -12. And we're going to list all of the prime factors inside of the radical. How many 3's do we have right here? We have 3's. Put 3 times 3 times 3. How many 5's do we have? 2. Put times 5 times 5. Now, if you can't see the index, what do we know the number is going to be there? Even though we can't see it. A 2, because this is a square root. It's a radical sum. Now, square roots look for groups of 2. I have a group of 2 right here. I have a group of 2 right here. Right? So I have a 3 squared and I have a 5 squared. So what can come out? I can pull out a 3. What else can come out of this radical? I can pull out a 5. But what do I do with the -12, the 3, and the 5? I don't add them together. I have to, these are dealing with factors, right? So I have to multiply all these together. That's right, 15 times -12. It's just a -180. But what do I still have left lingering inside of the radical? 3. That's your final answer. Totally simple. All right, last problem, everybody, is problem number 5. All right, what I want us to do is I need us to break down the 20. We're going to break down the 20 into 4 times 5. And we're going to break down the 4, 2, and a 2. What do square roots look for? Groups of 2. Do we have a group of 2? Yep, right here. So what comes out of this radical? The number 2. What's already sitting out there? A 6. So what's 6 times 2? We have a 12. And what number do we still have hanging inside of the radical that did not have a pair? The 5. So the 5 stays inside of the radical. So 6 radical 20 actually simplifies to 12 radical 5. Now, what does the 5 break down to? A 5 and a... Oh, guess what we can't simplify? We can't simplify this, so that just becomes what? We're going to put plus 8 radical 5. Now let's break down the 45. What does 45 break down to? 9 and a 5. What does 9 break to? 3 and a 3. Do I have a pair of 3's? Yep. So what comes out? A 3 comes out. What's already out there? -5. What is -5 times a 3? -15. So I have a -15. Radical what? Radical 5. Now what if the problem was 12a plus 8a plus 15a? You just add like terms, right? Because all the a's are alike. So what's 12 plus 8 minus 15? 12 plus 8 is 20. Minus 15 is what? 5a. So your answer would be 5a. Radicals work the exact same way. I can only add or subtract radicals that have the exact same number inside of the radical. So what is 12 radical 5 plus 8 radical 5 plus, minus 15 radical 5? And this is your final answer, 5 radical 5.